morning from Beijing. We are very honored to have you all to attend today's session, Bamboo for Carbon Neutrality and Green Growth. It might be a little bit early for some of you, some of our speakers and audience. So we are very appreciate your participation. Climate change is real. It is already severely impacting every part of the world with extreme weather events, droughts, floods, heat waves, heavy rain, and other weather-induced disasters. Over 100 countries across the world have set an ambitious target of achieving carbon neutrality by the middle of this century. Important countries such as USA, China have pledged to achieve carbon neutrality by 2060, and India has announced that it will achieve carbon neutrality by 2070. To achieve carbon neutrality, greenhouse gas emission needs to be counterbalanced by carbon sequestration. At the same time, we need renewable material to substitute for high carbon intensive products. Bamboo is an excellent resource that could contribute to achieve carbon neutrality and green growth. This technical session will delve on the potential of bamboo for carbon neutrality and green growth. Today, we are glad to welcome 7 subject matters experts and researchers to deliberate from different thematic aspects. Before we start, I would like to share some instructions with our participants online. Today's session will be recorded and posted online. This session has Chinese, English simultaneous translation. Please choose your preferred language in the interpretation option. First of all, I would like to welcome Mr. Jayalaman Durai to deliver us the keynote remarks. Jayalaman Durai is the Director of Global Program at the International Bamboo and Rattan Organization. For the past 20 years, Durai has designed and managed large-scale bamboo-based livelihood development and environmental management programs across China, across Africa, Asia, and Latin America. Durai has extensive expertise and knowledge in bamboo-based livelihood and environmental development, capacity building, partnership development, and policy aspects. His presentation is on the potential of bamboo for carbon neutrality and green growth. Mr. Durai, please.
Thank you very much, S4.5, for the introduction. And some good morning and some good afternoon and some good evening for the participants online and the panelists as well. So my presentation is on the bamboo, the suitability of the bamboo for the carbon neutrality and green growth. So my presentation will have 3 or 4 sections: a brief introduction of INBAR, brief introduction of the bamboo suitability, the potential of it for the carbon neutrality and green growth, and then the conclusion. So INBAR, as you know, is an intergovernmental organization. It has 49 member countries, which has the headquarters in China. We have regional offices in Cameroon, Ecuador, Ethiopia, Ghana, and in India. In bamboo is like in wild grass. Many people say it is a tree. Many people say it is a grass. It has the properties both of the tree and as well as a grass. It embodies some 1,642 species which are known. Around 35 million hectares of own bamboo resources are there. The internal production and consumption of the bamboo is about $70 billion with an international trade of about $3 billion, and approximately 2 billion people depend upon bamboo. They produce or they consume, they trade, they value add in different forms. And around 9,000 products and applications are available in bamboo. As my colleague S4.5 mentioned, climate change is real. It is impacting the world. The carbon dioxide concentration in the atmosphere has been ever increasing from 1950s or even some before that. The severe droughts, cyclones, typhoons, diseases, so many troubles, the impact are still unknown. So it is already strong enough for the human being. So carbon neutrality pledge, different countries, the UN bodies have been making, it is to make the carbon dioxide emissions and the carbon dioxide sequestration the same. So it is to balance, so it is to neutralize that. How can bamboo contribute to that? Bamboo, as you guys know, is one of the fastest growing plant in the earth. It can sequester and store more carbon than the fast growing trees. And there are so many scientific researchers in China, India, Latin America, in Africa, and different species to validate it. And then there is a possibility of 10,000 product and application, and then the bamboo natural material is highly biodegradable. The production process is low carbon footprint. These are all the ways. As I have indicated earlier, it is a woody grass. It grows annually, it produces new shoot annually, and then which provides the possibility to annually harvest it. It's not a tree. When you cut it, it is gone. Then the pathways for restoration. There are two main pathways to bring the carbon neutrality. The one is to do the restoration and then some sustainably manage the bamboo resources, which is already there, and then produce low carbon intense products. There are so many products, some possibilities available. Short-term goods to long-term goods to mid-term goods. You can name any product, any applications where the bamboo could be possible. Plenty of product, plenty of applications, plenty of stuffs are possible with bamboo. The first, how can the carbon sequestration or the bamboo as a forest can store carbon? Different researchers in different species indicate that the carbon stored in the bamboo forest ranges from 94 tons to 392 tons per hectare. It has annual higher rate of carbon sequestration, which is up to 25 tons per hectare. If we compare the bamboos with the trees and with forest, the bamboos perform better than tree plantations, but it is not, and then it is comparable to the forest plantations. This is the annual carbon sequestration rate. For some species, the sequestration rate is 2.5 tons per hectare, and for other species, the sequestration rate is 25 tons per hectare. The storage of the carbon is above the ground biomass, below the ground biomass, leaf litter, and so many other forms. The storage in products. As I have indicated, there are so many product possibilities. The production is low carbon intensive. There are so many researchers on the LCA, which indicates the suitability of bamboo. I think one of the speakers in today's session, Professor A. Wang, he has done research in the carbon LCA aspect, which he would be elaborating more. And then the green growth is possible with different enterprise possibilities. As with many other crops, all the parts of the bamboo can be value added into different products. You can start an enterprise with zero investment, or you can have a factory with an $1 billion investment. Different enterprise possibilities, household and micro, small, medium, large, very big industry possibilities are possibilities with bamboo. All the components of the bamboo can be value added into so many other product forms. The different pathways, how bamboo can propel green growth and to bring carbon neutralities. The bamboo construction is a very important area. You can do construction with the whole culm without processing it, and at the same time, we can value add it into different commoditized panels, the scrimber boards, laminated boards, the particle boards, the medium density fiber boards. So many products and applications are there. I think one of the speakers in our panel would be speaking about the bamboo construction and its suitability. I think it's Professor Edwin. And then energy. You can convert bamboo into different energy forms, solid, liquid, and some gaseous fuels. I think our panelist, Mr. Chaya Wahano, would be speaking in depth on his case study in Indonesia, how bamboo could be promoting the green growth and at the same time mitigating the carbon through their electricity generation product in Indonesia. And different like some single-use plastic products are like some possible with bamboo. The alternatives for fiber, alternatives for like some pulp and paper, alternatives for the polyvinyl chloride, alternatives for other energy-intensive materials which are plastics are quite possible with bamboo. And at the same time, you can produce the plastic substitute product from different enterprise options. So one of the speakers, Salim Raza, would be speaking about his example and his enterprise models, which he developed in like some Kenya and in other places. And like some currently, if you would have seen yesterday's inauguration session, speakers have spoken about the plastic alternatives product with like bamboo, with like panel. And here's like a picture. The first picture shows the pipes, the huge pipes, which are like possible from like some bamboo. So there are so many enterprise possibilities, small, medium, micro. You can start an enterprise with different product ranges, and all the parts of bamboo can be value added. There are so many pathways by which we can include bamboo as an carbon neutrality material and as well as a green enterprise development like a material. So in conclusion, I want to state that bamboo can significantly contribute to climate change mitigation. And by the way, it contributes to the climate change neutrality, and it propels the green growth through the enterprise development options. It can store carbon in the forest, in the soil, above ground, and like below ground. And also, there is a huge possibilities to alternate bamboo product with high energy intense like materials. Thereby, it like reduces the pressure on the forest, and at the same time, it reduces the need for high energy intense like materials. It can be as a renewable material. It can aid in green growth with the wide product possibilities and with wide enterprise possibilities. I join my colleague like Renfai in again like welcoming all the distinguished like some panelists to our like some session to illustrate more, to elaborate more on their individual case studies. So without taking much time, I thank you all, as well as I thank all the participants in our participant in our section. Many thanks indeed. Over to you, Renfai.
Thank you very much, Durai. Many thanks to Durai Jayalaman for elaborating the potential of bamboo for carbon neutrality and green growth. With that, I would like to introduce our first speaker of today, Mr. Jaya Wahono. He is the founder and CEO of Clean Power Indonesia, which is an Indonesian company that specializes the development of community-based energy forest and the utilization of biomass gasification technology for various applications. He will introduce the integrating landscape restoration and bioenergy in Indonesia. Mr. Jaya, the floor is yours.
Thank you. Can you hear me, Renfai?
Yes, perfect.
Okay, very good. So I will share the presentation. Can you see it?
Yes.
Yeah, okay, perfect. So like Renfai mentioned, my name is Jaya Wahono. Good morning, good afternoon, good evening, everyone from all over the world. I'm from Clean Power Indonesia. We are independent power producer in Indonesia, based in Jakarta, the capital city of Indonesia. But most of our project is in the underdeveloped region of Indonesia, mostly in eastern part of Indonesia. So if you're not really familiar about Indonesia, Indonesia is the biggest island nation in the world, or archipelago country in the world. We have about 17,000 islands all over Indonesia. Of course, most of them are not inhabited, but even the inhabited islands is around 9,000. So it's a lot of islands that need access to energy. So even though that we have many natural resources, we are rich in coal, we are rich in oil and gas, we are rich in all of the renewable energy resources, but it's very difficult to distribute this energy into the population that live mostly in the eastern part of Indonesia and also small islands. So that's why many people still live in energy poor condition. So this is what I would like to change in Indonesia. So and we found out that bamboo grows in Indonesia, all over Indonesia, in small islands also, so we can utilize that. The problem that we have here in Indonesia, because of the many islands, PLN, that's the state-owned utility company, has to generate power from diesel fuel. And as you know, diesel fuel is very expensive. It costs about 30 to 40 cents per kilowatt hour, even though that the electricity sales to the population is only 3 cents per kilowatt hour. So the government has to subsidize the electricity. Now, when I propose to the government, look, we cannot continue doing this, so we have to, why don't we just use local renewable energy, such as hydro, solar, and biomass, then the government asked me to put a pilot project. So we put a pilot project using the biomass, bamboo mostly, that is cultivated by the local community, and we show the government that the cost now comes down to 12 to 15 cents. So the government will save like 50% and more. And not only that, but also the local community will have much reliable power. And also if there is a natural disaster hit to this area, they're still going to have a power rather than relying on diesel fuel that need to be transported from other islands. So this is the location where we put the pilot project. It is called Mentawai Island. It's in the western part of Indonesia, off the coast of Sumatra. And we are asking the local community to grow the bamboo, and it creates employment. And they supply the bamboo to the power plant that we built. And then we distribute back the electricity to the community through the PLN, which is the state-owned utility company. And the lighting and economic activities grows very, very fast. This is the looks of the pilot project. This is the first in Indonesia. I think it's also the first in Asia Pacific that using bamboo that is grown by the community. So we are kind of proud about this achievement that we would like to replicate to all over Indonesia. It is inaugurated by the Minister of National Planning Agency back in 2019. So the minister also showed to many local government to duplicate this model in their area. Now, the first pilot project was funded by grant from U.S. government. So we cannot rely on grants for the replication. So I came to the government of Indonesia, and in this case, Ministry of Finance, and they have a new agency called Indonesia Environmental Fund, and they got the funding from REDD+, which is the reduction of emission through deforestation or land degradation. So Norway put money into that new agency, and we asked the government to supply that funding into the local community and also the state utility company to become incentive, so they will be willing to grow the biomass for our power plant, and the state utility company willing to be off-taker of our electricity. So in this case, we don't really need a grant anymore from foreign government, because this way it's a direct benefit from the carbon credit. Because we grow the biomass to absorb carbon, and also we reduce the carbon emission from the power plant. And I have collaborate with C4 ICRAF, which is the forestry think tank based in Bogor, Indonesia. and they just released this finding into the book called Bioenergy for Landscape Restoration and Livelihood. I wrote in chapter 14 based on the lesson learned from the Mentawai project. So this is something that we want to share to other countries all over the world. The lesson learned not only about technology, but also the model that we think it will be more sustainable for this biomass production. And we also collaborate with the Alliance of Rural Electrification. They are based in Brussels, Belgium, and they wrote a case study, and our project was also featured there in this case study. And they find out that compared to hydro and solar PV, our biomass power plant, the community-based biomass power plant model creates much more jobs and also avoided or sequestered much more carbon emission. So I think this is logical because we can generate electricity 24/7 and also year-round, as opposed to solar PV only generate electricity 4 hours per day. And during the cloudy condition, then they also cannot produce electricity. And then the small hydro also cannot produce electricity during the dry season. So biomass can be solve all those problems because we can generate electricity as a base load. And working with the C4, we promote not only the energy from the bamboo or biomass that is grown by the community, but also we're thinking about creating what we call the bioeconomy. So it can produce biomaterial and also for carbon sequestration. In Indonesia, there's about 14 million hectares. 14 million, that's a lot of land that is degraded, critical land that government aim to restore and put it into the NDC. And that will require about $34 billion of investment. If it comes from the state budget, then it's going to be very difficult for our government to deliver. But combining this with the private investment, then this becoming more manageable. And we have to do this by 2030, according to our NDC. And I guess the key message here is bioenergy is actually strengthen the economic incentive for the private sector and community groups to undertake restoration effort, because without the bioenergy production, then there is no economic benefit to the local community and very difficult to mobilize the private sector investment. But of course, we don't want to approach this from monoculture or land grabs, because that's going to be causing a lot of social tension. So our principle of 4R, we call it 4R, right crops in the right landscape with the right business model and respecting the rights for the people. And if we manage this well, I think this is not going to be a conflict between energy and food and land utilization. C4 also mentioned that there are 3 species or types of plant that really potential in Indonesia. One is Tamanu tree, 2 is Pongamia, and 3, of course, bamboo, because it's easy to grow. It has many function. It's native to Indonesia. We have about 200, I think, endemic Indonesian bamboo species, and it can be combined as a bioenergy and restoration all over Indonesia. And the other thing also regarding the technology, because we're not only producing energy from the syngas, because we gasify the bamboo into syngas, and syngas going into the gas engine and generate electricity, but we also have a byproduct. It's called biochar. And biochar is a carbon sequestration. It's cited as a promising carbon removal technology and soil improvement, according to the European biochar certificate. So we can use this to offset our nickel production in Indonesia, because now we are becoming a major player in nickel exporter, mostly to China, of course. And this is going to be the next energy transition that impact the whole world energy transition. And because Indonesia is a nickel producer, then I think it's very natural that we also offset that carbon emission from that nickel production here. And I think bamboo has a very, very good potential to do that. Indonesia, as you know, has two main carbon emission reduction target. One is from the forestry and other land use, and the other for energy transition. But 90% of the energy transition money that we need has to come from outside of the government budget, as opposed to the forestry and other land use. Now, government also putting money into the land restoration along with the international donors, and this is much more manageable because then the energy transition, if it's separated from land restoration and livelihood improvement, it's becoming very expensive for us. We cannot afford it. We still have a lot of people living in a poor energy condition. So I think it is wise for the government to focus on land restoration instead of energy transition, while we do the transition in the area that is more manageable for us, such as replacing the diesel genset. So the impact is very big. In Indonesia, there are about 25,000 villages. I think it's about 40-50 million people living still under unreliable and equitable access of electricity. So if we don't solve this, then the poverty will persist. Then I think this is the main target for the government. We are more about alleviating poverty rather than just doing the energy transition. Number two, of course, we want to restore these 40 million hectares of degraded and marginalized land that will increase carbon sequestration for our benefit and for the global benefit. And also we want to have a much more energy security, because this is the main issue now. While inflation is so high everywhere in the world, we want to rely on our energy sources. And we can do that. And I think the opportunity is big also there. So the last slide, the last conclusion, we're going to host the G20 government in Bali next week. I think bamboo is going to be a very good candidate for creating all this benefit for the G20 countries, especially Indonesia, and Indonesia can promote this. Number one, it will create jobs all over Indonesia, which is desperately needed now. And we also can create energy self-sufficiency in all regions, not just in Java Island or the big cities. And then we also want to reduce cost of generating electricity and rely on local source of energy. So we can do that with growing bamboo in the community land. So I guess this is something that we're determined to do in Indonesia, and hopefully we can collaborate with INBAR in the future. Thank you.
Thank you very much.
Back to you, Rainfei.
Yes, thank you very much for showing us a very inspiring case study which is a community-based biomass power generation model. Now, I would like to request our IT team, could you please the short video of Jaya, Mr. Jaya? Voice.
Indonesia is the biggest arc in the world. And for decades, Indonesia has been relying mainly on fossil fuels as an energy resource. At the 2015 UN Climate Change Conference, Indonesian President Joko Widodo said that Indonesia would show its commitment in promoting a renewable energy and sustainable forest management. The target is to achieve 23% of new renewable energy utilization by 2025. Renewable energy resources that can be used in Indonesia are hydro, wind, geothermal, solar, and biomass. Hydro and geothermal sources are not always available in many islands like wind, solar, and biomass, which can be developed in a microgrid environment. Solar and biomass can correspond to one another by adjusting the existing land and following the availability of raw materials. The optimal combination of solar and biomass can result in up to 100% decarbonization. Geographically, the most suitable and effective energy resource for Indonesia is biomass, and the most abundant biomass resources able to be utilized is bamboo and gamal. Bamboo and gamal are native species and environmentally friendly plant that can regenerate quickly and easily. When using bamboo and gamal as an energy source, Indonesia gains major benefits such as, compared to diesel, bamboo is 30 to 35% less than diesel. 4,000 tons of bamboo per month can produce 5 megawatts, which can electrify 5,000 houses. Helps restore large areas of degraded and underutilized lands in most rural communities. Every 100 kilowatts of PLT biomass will create 45 workers from upstream to downstream. A bamboo-based biomass power plant model was proven in 2018. Clean Power Indonesia has finished building a bamboo-based biomass power plant in 3 villages on Siberut Island, Mentawai Islands, which generates 700 kilowatts of electricity to 1,300 households by creating 450 jobs directly. This model can create a sustainable financing environment. How does sustainable financing environment work? First, local communities or villagers play a role in production and supply, which results are then given to developer of the biomass PLT to be converted into electricity. The electricity is then sold to PLN, which in turn distributes electricity back to the community. This has proven to be the most efficient way of providing electricity to remote areas as well as limiting the use of fossil fuels as an energy source. Clean Power Indonesia is determined to increase biomass energy by replicating bamboo and gamal-based power plants, with the hope of producing a green environment and equitable distribution of electricity throughout Indonesia.
Instruction. I would like to kindly remind all of our panelists to mind their length of your speech because the time is very limited and the next session is waiting in line. Thank you very much. Now I would like to introduce the second speaker of today, Dr. Edwin Zia Escamilla, who is the chair for sustainable construction of Swiss Federal Institute of Technology in Zurich, and also the member of Bamboo Construction Task Force of INBAR. His research focuses on the life cycle and sustainability and analysis of construction materials and buildings. Today, he will talk about life cycle assessment of bamboo-based buildings. Please, Mr. Edwin, the floor is yours.
Thank you, Renfei, for the introduction and, of course, for the invitation to present our work here. Just one second. It's very, very early in the morning for me, so please bear with me. I don't know why my Zoom is not showing. Oh, no. Sorry, do you see the presentation?
Yes.
Okay, thank you so much. Sorry for that. So let's jump right into it. Fortunately, I had two very good presentations before me, so I don't have to spend too much time on it. We all know about the bamboo and its properties, and the invitation today is to think beyond the forest. That's the most visible part when we think in terms of biogenic carbon storage and sequestration. Of course, there's where it happens, but this isn't only limited to the life cycle of the forest itself, which in the case of bamboo is relatively short. So the invitation is to think in buildings, which expand this life service of the product and indeed increases the carbon storage time frame where we're operating. This presentation today is mainly about the bamboo frames, so buildings using ground bamboo. But we would encounter a very similar situation in industrialized engineered bamboo products. And somehow is mentioned all the time, but the big question, at least for me many years ago, was how do we assess this, how do we calculate it? And just very briefly, in terms of methodology, the life cycle assessment is a well-established methodology. Indeed, serves as basis for many of the reporting and environmental declaration schemes that we have around the world. Sometimes they are more known than the actual methodology behind it. And what is interesting is a holistic approach. We consider every land use, energy, materials, and factors, all the factors, all the inputs that we require for the production of a product, of a building, and then is able to assess the total impact through the whole life cycle of the product. And is, as I mentioned, well established, is in the ISO norms for decades now. And the message here is also the importance of the LCA and its results is it produces information that we can use to take decisions, whether to improve a process or to validate a system that we have. And that's very important now, at least in EU area. We need to have an LCA if we want to claim a product as sustainable. So it's important to understand that the LCA gives you tools, but doesn't make the product sustainable on itself. And we have been working for more than a decade now on this. The LCA is a data demanding and data driven methodology, which for the case of a product like bamboo, it's been very difficult, or was very difficult for many years to produce high quality data, especially because we have very diverse production processes. Every production and operation works different. It's mainly medium and small production. It's changing, and of course, China is the front runner in these large scale operations. And it was very difficult to also to fund this kind of research. I must say thanks to many commitments and collaborations with INBAR and universities and different associations, we managed to publish last year, 2021, the first official, let's say, data sets for bamboo-based construction materials, forestry and construction materials, low industrialized construction materials that are now available in the largest database in the world, that is EcoInvent. So that is somehow also the foundation to the work we're doing, and that is now open to anyone who can access this and wants to work in this field. I don't want to go too in detail. We have been, as I mentioned, researching the impact and environmental saving potentials from bamboo construction for more than a decade now, and we have studied in all different possible combinations that you can imagine, and the result is always the same. Bamboo has indeed a very, very significant environmental saving potentials. It changes dramatically depending on type of production, on the electricity used, and also on the transportation needed for different products. But in general, we see in the case of building savings from up to 60% when comparing buildings with the same properties and performance. This is a case of we this year actually in the Philippines, And this is very important, looking at the structural behavior of the building and how it reacts and influences other parts of the Thailand. Now, one of the big challenges that we see, especially for social housing, is to find solutions for the foundations, actually, because with the bamboo, the reduction and the impact is so low that there's not much more that we can do there. But still, especially the use of cement and concrete is very significant, and probably the next target if we want to achieve net zero in buildings. It was mentioned before, but I think we need to understand when we are talking about biogenic carbon storage that there is also a dynamic process here. If we look it from an static view, basically it's clearly seen most of the biogenic carbon stays in the forest, and around 7% stays in buildings. So, okay, well, it's a relatively small thing. But when we look this in a dynamic perspective and see, like in this case, the productions through years, this is the production from a relatively small plantation that we were studying, and we see this multiplying effect that the buildings have. The important thing is we see at the end the bamboo forest stays somehow stable, because what is decaying and emitting is growing again, so that there is somehow a plateau. But if we start creating a new carbon sink in form of buildings and the built environment, then we can see how the carbon storage was first in the bamboo forest can now really significantly increase when we use it in building. And beyond that, very important to think about is in this case we are looking at social housing. It's a very, very large housing gap that we were facing worldwide, and in this case in the Philippines again. And then we see if we just plant forests, of course, you can have a significant storage capacity there, but with additional investments, because this doesn't, this requires investment, then not only we all more than double the storage capacity that we can generate for one bamboo plantation, but also we are providing yearly enough materials to build these houses and homes for the most needed. So this is this multiplying effect that I mentioned, and that is very important to have. Just to close and to echo the previous presentation, and I would say beyond sustainability, bamboo is a regenerative construction material. The more we plant, the more we use, the better for us, better for the environment, the better for the economy. So, but this only happens if we build strong value chains around not only the forest, but the materials and the houses. And it's clear that bamboo is the material that can spearhead the transition to our net zero built environment. And with that, I thank you for your attention.
Thank you very much. Thank you very much. And we really appreciate your commitment and support to this session. That we understand we are based in different time zone, and the time is not very friendly for you who live in Zurich. And thank you very much. Now I would like to move to our third speaker, Mr. Chen Tanglong. Chen Tanglong has been working for more than 20 years in many countries for several national, international organizations and consulting companies. He has worked for INBAR as a program coordinator for global assessment of bamboo and Rattan for green development program. He's currently working working for Face the Future company specialized in forestry carbon project development and management. The title of his presentation today is Bamboo Carbon Sequestration, Certification and Trade.
Good morning, everyone in the room. Good morning, good afternoon, good evening. Good morning for the people who are watching this section online. My name is Trinh Thang Long. I'm working for the company called Face the Future. Face the Future was established in 1990s, and we are based in Wageningen, the Netherlands, and we are specialized in development and management of forest carbon projects. We have support development of many forest carbon projects in Africa, Asia, and Latin America. And we also manage our own projects in Africa and in Asia as well. Today, I will talk about the potential of bamboo for climate change mitigation and certified bamboo projects and trade the carbon emission reduction from bamboo forest. So my presentation it covers 5 subjects. Very briefly about the global voluntary carbon markets and bamboo carbon sequestration, and how to certify bamboo forest projects, and how to get funding for that, and my some recommendation. So if you can see in the graph, here is how is the carbon transaction in the volunteer markets over the last decades. In general, the carbon demanding or amount of carbon credit transaction in the market is rather stable, even it almost fluctuated a bit. But unless except the year 2021, the carbon transaction is jump up very high because of the also after the COP26, many company and other private sector, they realize that it's important to offset their emissions, so they have more demand, higher demand. In 2022, we don't have the data yet, but it must be higher. And in terms of carbon price, you can see here for 2 years here, 20 and 2021. In forestry and land use sector, the carbon price is second. It range between 5 to 6 ton US dollar per ton of carbon dioxide. That is only 2020 and 2021. In 2022, the demand for carbon credit increased and carbon price also increased. Under LEAP coalition, they already reserve price for $10 per ton of carbon dioxide of emission reduction from that project. It means that you cannot sell lower than that. If the market price higher, you can sell higher, but lower you can sell to them for $10. And price will be increased if you develop a project which provide co-benefits. What means co-benefit? It means that the project is not only aimed for emission reduction for term, but it also provide net positive benefit to communities and net positive benefit to biodiversity. Currently, we see the sales price in the market is ranging between US $15 to $25 per ton of carbon dioxide. This is a very good opportunity for forest sector in general, particularly for bamboo sector, because high carbon price, and then with the bamboo, we have a lot of advantage here. What I will tell you, the first, bamboo is one of the fastest plants on Earth. They have very high annual rate of carbon sequestration, and bamboo have very short harvesting cycle. Once you plant them, after 4 or 5 years, you can harvest them. You can harvest annually, and the new calm will replace the harvested calm. Annual harvesting it not disturb, not harm to the bamboo plantation. When you plant bamboo, it's easy to achieve co-benefits because bamboo provides significant amount of raw material that will be used for economic development. That community will benefit. They can sell the gum or they make use of gum to make product. And bamboo plantation also provide other ecosystem services such as erosion control, landslide, and biodiversity value, of course. So it easily to achieve co-benefit from bamboo plantation. If we look at in general, globally, carbon storage in bamboo plantation ecosystem, it range around 94 to 392 tons of carbon per hectare. That is similar to amount of carbon storage in pre-plantation ecosystem. I mean, yeah, it's from soil, above ground, below ground carbon. Huh? It's, here, I mean, here it's amount here carbon. Is 1 ton of carbon is equivalent to 3.67 tons of carbon dioxide. Even that carbon storage in ecosystem of bamboo and tree plantation are similar, but bamboo has much more advantages here. Annual rate of carbon sequestration from bamboo forest can reach to 25 tons of carbon per hectare per year. This is twice as much as that can do from the tree plantation. For example, eucalyptus plantation, they can sequester around 10 tons of carbon per hectare per year. Here is bamboo is twice more than that. This means that in the short period, the bamboo plantation can already store full capacity of carbon storage in their plantation. While for tree plantation, it may take longer. Normally, bamboo is around 10 years. They can store full capacities of the carbon inside their ecosystem. Of course, including soil carbon, it takes a little bit long, but only above and below ground biomass, around 10 years, it's already there. While for tree, it will take 20, 50 years to reach that level. So it's much, much higher. And can carbon sequestration from bamboo forest be traded? Yes, it is traded, allowed under IPCC's guideline for national greenhouse gas inventories. Carbon in bamboo is also accounted. That means that you count when the emission reduction from bamboo forest can also be counted there, or it's stored there, you can count it. When it's counted, that means you can trade it under the condition that if the if the bamboo plantation is certified under certain standards, then to make sure that it is real, then you can trade it. Yeah. And how can you certify a bamboo forest? There are many ways. If you want to trade in compliance markets, you have to use their criteria and standards. Yeah, it's many different standards. There are for certain country, for least development country, developing country, or developed countries, and then there are a number of methodologies developed under their standards, such as in CDM. But in G1, I will say here is the standard under volunteer carbon market. It means that you can develop it for small scale, you can sell it there. It's a little bit different between compliant and volunteer market. That is alone, I will not say more about that. That here the volunteer carbon market is mostly common one is here Vera, the VCS, Plant Vivo, Gold Standard. This all are the standard. Here you can develop it and you can trade it all over the world. So how you can develop that? Here we propose here it's 5 phases. Mostly apply in G1 is similar to Vera procedure. The phase 1 is to develop a project idea node. Project idea node is a short, simple description of social context, land context, land tenure, biodiversity condition, what activity you are going to do, what expected emission reduction can be achieved there, very short information like that. And then once you that is an idea note, you can do mostly by on literature review. And then you come to phase 2 is feasibility study. If you see that, okay, the emission reduction is good enough, you go to feasibility study. Feasibility study will more go into the ground to do quick assessment of ground condition, talk with stakeholder if they agree with the project or not, and then quickly assess potential impact from project to community and biodiversity, assessment of risks, assessment of potential emission reduction, and consider the cost analysis, see how much revenue from carbon you can earn from the project, how much investment it could be, investment for project development, investment for project implementation, and if economically is feasible, you go to project development phase. This one is to design and develop the project. This one is much more detailed. It can be half years or 1.5 years, or if complicated project, it may take even 2-3 years. So you have to conduct the ground assessment, the baseline assessment of additionalities. Additionality saying that the project carbon emission reduction is not under business as usual scenario. It has to be something new added to it one because of the project. Then you get emission reduction. So and then you also conduct risk assessment, all different risks, and you have to ensure that there is no net harm to communities, biodiversity, and environment. In case you want to get project certified with co-benefit, then you have to conduct social biodiversity impact assessment, and to ensure that project will also provide net positive impacts on communities and biodiversity. So you have developed 3 monitoring plans. One climate monitoring plan to monitor the carbon change, a community monitoring plan to monitor the project impact on community, and biodiversity monitoring plan to monitor the impact of project on biodiversity. And go to the validation. After you develop the project document, design document, you register under certain standards. They will also provide list of certain validation body. You can select one of them. They will come to check whole your project, make sure that the project meet all the requirements from standard, from methodology. One is fine. Then they will recommend to the standards the project is qualified, will be validated, and then verification. That is the phase that also another external verification body come to your project to check with all your monitoring data to ensure that your monitoring data activity correct, the carbon increase chain or amount of carbon chain is correct, impact on community, impact on biodiversity, okay, everything okay. So they will have a validation report to the standard, say that okay, this project achieves it, this much of carbon emission reduction achieves it. Then the standard will issue the carbon credit to you, and you can sell it. The whole of it is a process. It can take quite a long. You can see the time in the slide. And the cost, it varies, depend on the complexities of the project. It can range between 300,000 to 600,000 US dollar. Some can be more. No? So where you get funding for certify the project, it only the cost for certify, but it also the cost for implementation of the project. What means including setting up the nursery, planting tree, management, product development as well. There are a number of carbon investor. For example, climate impact partner, carbon neutral groups, and this one they provide funding, pre-funds for the project development and implementation. They will discuss with you on the make an agreement with you on revenue sharing from carbon credit sharing between them and you. They provide fund for investment. and how you can connect to it. We can introduce you to them, or there are also number of platforms. You can upload your data, your project information on the platform, and they will contact you. This is a platform you upload there is free, but they have to verify the information, and then they can connect there to you. So my conclusion for this one is that bamboo have high potential for emission reduction, and then emission reduction from bamboo plantations forest can be traded if you certify it. What I would like to recommend is governments, international and local organizations should support smallholder to certify bamboo plantation project, then enable the smallholder to manage, to develop and manage their plantation, at the same time can sell the carbon credit, help to the community development, help to climate change mitigation, also help the biodiversity as well. The key point for carbon projects, the project certified is minimum is 20 years. It can be up to 100 years. Therefore, the long-term commitment from project and international organization is required. That is my presentation.
Okay, thank you, Renfe, and chairman of the session, the Jayaraman Durai, and our respected panelists.
Salim, could you please make it the full screen?
Okay. Now I think it is full screen.
Yes, thank you.
So now welcome to this presentation. This presentation, actually, we are highlighting how the micro enterprise, especially the bamboo micro enterprise products as a plastic alternative, and how that is creating the rural employment and livelihood, and also the contributing in carbon sequestration. This is the some flashlight, how the bamboo, this is the dynamics of the bamboo-based enterprises. This is the it creates community-led livelihood and employment opportunity. Also, it capitalizes the traditional knowledge and skills. In rural areas where the bamboo is growing, people have the traditional knowledge and inherent skills. And this bamboo can help our enterprise, can help our products development, and also the rural employment opportunity through enhance their knowledge and skills. And it generates quick return with the minimum investments, because when we'll go for the micro base enterprises in the bamboo, so that it can create the quick return, because no need more investment at the initial step, but it is again the size of the enterprise. If it is the go for the big modern technology, that can be also possible. It contributes in the national economic development, because the micro enterprise is always it is a kind of it is also one of the economic driving force of a national economy, because small enterprises create a lot of job opportunities and employment in the village, and also contributing to the growth in the GDP of any nation or of a country. Moreover, it creates awareness for the green product with reference to the climate change. The small enterprise of these sectors can create the enabling environment for the consumers, and definitely in the creating the climate change, contributing in the climate change. These are some products. You can see the plastic products versus bamboo alternative plastic products. This is the spoons, and this is also the bamboo-based spoons. This is the glasses of the plastic glasses versus bamboo glasses. This is the straw, huge. Yesterday, when our inauguration session, there is our some dignitaries giving presentation how the plastic straw versus the bamboo straw. Bamboo straw, how can contribute for the carbon sequestration as well as the neutralize the carbon as well as the to the production of our environment. Also, we can use the laundry baskets and the litter bins. These kind of products we can produce in the micro level in the village and the community for these sectors for the carbon neutralization. Then question generally coming, what is the how we can do it and where we can our positions in this micro enterprises of bamboo for the plastic alternative products. It creates multiple avenues for the carbon neutrality scopes and opportunities. In different ways we can do for the big large product, for the high-end product, engineered bamboo product, to micro level products, household utility, consumption utility, daily use products. We can also do for micro enterprises. A sustainable livelihood business, we always talk not only the livelihood, it is also a business. When we are talking of the community improvement, economic employment, job creation, green jobs, green business, so that bamboo, this micro enterprise can definitely give the opportunity for us. Acting in circular economic development, the bamboo is a circular economic development is contributing because when you will use it, then it can also reuse. Like example of the bamboo toothbrush handles and plastic toothbrush handle, we can see that is also not possible to recycle. But in this bamboo handle, plastic toothbrush handle, after use, the end use also you can recycle for the bamboo charcoal or maybe craft-based product and others products. So that is in contributing the circular economy, creating green jobs and green business, and definitely also inviting the green financing. In this micro enterprise of the bamboo carbon sequestration activities, we can create three dimension approach. We can create employment as well as the green job, and also we can encourage green business. This micro enterprise bamboo for the plastic alternatives, we can also accomplish in few number of SDG, SDG 1, SDG 5, SDG 12, and SDG 13. Finally, the bamboo product contributing in carbon neutrality globally. Because this product, when it is producing in a small village, it is going to regional, national, and international market. So that we are contributing in a globally for these products. These are some enterprises. It is happening in the India, Africa, Kenya, Uganda, Ethiopia, Madagascar, Tanzania. Everywhere we can see the small enterprises. Through our intervention in our programs, INBAR, Dutch and East Africa bamboo development programs, we are community develop, providing that skill training, design, capacity buildings, and the business development services to establish the micro enterprises producing the plastic alternative products. These are from the Kenya, these are from India, also there is from Ethiopia, and also from Uganda. So there is a huge opportunity to start small enterprises at the household level, community level, cluster level, and also after that is the graduating level, maybe for the micro to small and mediums. These are some of the products we can see. This is in our project we are contributing, and also people are already started and doing in a small to larger scale and graduating in the next level. And for the local employment, livelihood, and creating employment opportunity and overall carbon sequestration in overall opportunities. Now, this is the scope of the replicability in the different level, different scale in the different region. As per the opportunities and capacities there, bamboo-based SME produces zero emission and strive for the climate neutrality, because when you are promoting the bamboo at the household level, village level, or community level, this bamboo, when they are harvesting and they're making the product, the replacing is coming next year. So that we call the bamboo is a resource. It can be harvested ever and over and again. And this more you grow, more you harvest. So in that concept, it is a zero emission. So that whatever people harvest 3 bamboo and make the product, next year 6 or 7 bamboo will come up. So that it is a zero emission. so that it will be easy to replicate, promoting bamboo SME and creating bamboo product, a combination of lowering emission in the climate. That is also possible for this bamboo SME and micro enterprises. Bamboo SME and product provide a platform to draw eco-aware consumers in search of carbon neutrality. There are a lot of people around the world. They are searching for the eco product, alternative product, green consumptions, and green utility products. So bamboo can create an possibility for the people around the globe to encourage the eco consumers to buy this product for carbon neutrality. Bamboo investment attract favorable return on investment. There can be the opportunity for the green investment in these sectors, and it creates rural livelihood and contribute in local economic development. If it is the possibilities, because always it is the challenge for the create the employment opportunity for the rural poor and the youth and the women. So that bamboo SMEs can give the opportunity for the people in that context, in the different region in Africa and Asia, and any context we can replicate this approach and model for the carbon neutrality. But definitely there is some challenges in these sectors. There is no challenge, there is no success. So when there is a challenge, so that is challenge is the need for enabling environment for the investors, because there are a lot of issues and challenges, laws, business laws, rules and regulations. So we have to make a favorable environment for the investors. Mobilize eco-friendly funding or green financing. This is also another challenge. We are now, a lot of activities is going on around. People are now sensitizing, and now this is another challenge. Design new method of raising environmental consciousness. So we have to create a build and environmental consciousness, so that this is plastic products, this is bamboo product. Definitely the price is also another challenge, but we can make some things so that institutional procurement, there are a lot of issues are there. There are a lot of scopes are there where we can introduce bamboo product as alternate plastics, like in a different offices, schools, colleges, in institutional procurement. We can replace the bamboo plastic bins to bamboo bins. So litter bin. So in that way we can do that. This is the method how to do. Packages for the SME to decarbonize and adaptation of greener business practices to meet carbon neutrality goal. This is one of the challenges, because when we are talking before me, there my colleague, previous colleague, and the presenter given the presentation how we can take the opportunity for the carbon market. So still now the SMEs, they are producing a lot of products, but how the small SME can get the benefit from the carbon neutrality projects. So this is also another area. Second thing, the governments and other local government institutions should make some facilities for packages for the SMEs, so that they can produce more green products for the greener business practices. Promote the platform for the sustainable innovation hub as a knowledge center and knowledge transfer on bamboo alternative plastic products. In a regional way, south-south knowledge transfer, we have to create a hub where the innovations will be there, and the small enterprise can change, product can develop, the price can reduce, and more by diversification, the range of products and product verticals can things in these bamboo sectors for the plastic alternatives, more and more product. Permitting laws and policies to relax global norms and constraints for the bamboo products. When we are this issues also raised yesterday, because that some our honorable speakers they raised, because we need the global laws, we have to relax for the bamboo products, so that then participate can market from the beyond the boundaries. Facilitate trade more environment friendly for the coordinating, harmonizing and globalized market. This is one of the challenge we have to think for the small enterprises, so that can play more and more role in the carbon neutrality in a carbon sequestration platform of the SMEs in globally. With this few words, thank you very much.
Thank you very much, Salim, for your presentation, and thanks for introducing us the possibility of bamboo small and medium enterprises for reducing plastic pollution and achieving carbon neutrality. Now I would like to introduce our next speaker is Professor Wang Wei. He's the professor of Zhejiang Agriculture and Forestry University. His research focuses on sustainability, corporate social responsibility, forest and agricultural products marketing, corporate strategy, rural and regional development. Let's welcome him for his speech.
Thank you, Chairman. Can you hear me well?
Yes.
Okay, so dear friends, because of time limitation, so I'm go ahead directly to my presentation. My presentation will mainly focus on full utilization of bamboo in China. First, about bamboo utilization in China. So China boasts the world's largest bamboo forest area and also in bamboo diversity, and also leading in producer of many bamboo products. For example, China accounts for about 20% of total bamboo forest area globally, and the production output value of China's bamboo industry in 2020 was 320 billion RMB. Also, bamboo is a very important non-timber forest product for poverty reduction in the mountain areas in China, because more than 60% of land and also about 60% of people lives in the mountain areas in China. There are about 10,000 different kinds of bamboo products in 10 categories has been produced in China, from basic handmade like handicraft products to high value added products like bamboo plywood, bamboo furniture, etc. So the evolution of bamboo development in China has been clearly defined into 4 stages. The first stage is to the late 1980s. In this stage was mainly improve quantity and the quality of bamboo resource and develop traditional bamboo industry. So the handicraft and the semi-mechanization industry utilized in this stage. So we call this is before industrial processing stage, and majorly raw bamboo material or fresh products, handmade products. So the second stage is from 80s to late 90s. In this stage, processing machines have significantly improved their processing capacity, also increased the economic benefits of bamboo. Then scientific management of bamboo forest has been studied. So both number and the capacity of bamboo processing enterprises has significantly increased in this stage. So this is a primary stage of industrial processing. Many high value added products has been introduced, innovated in this stage. Then the third stage is from 90s to 2000s. So this develop eco-economy in order to sustain the integrated development of China's bamboo sector. So there are lots of policies and the new products and the new technology have been developed into this stage. So this is a rapid developing period of industry processing. So system products, also bamboo replacement of plastics has been, products has been significantly occurred in this stage. So the fourth stage is till to now. So the bamboo sector transferred from real production to a comprehensive high value and high efficient sector. So high value high efficient, multi-functions has been the major, focus into this stage and the strategy used in the bamboo sector in China. For example, many of you has been talking about carbon trade. So the bamboo carbon trade has been initiated in this stage in China. Then the biomass utilization rate was increased from 20% in the beginning to around 90% the current days now. So this stage is a transformation to a period of high quality and environmental friendly products like wood biomass pellets, bamboo biochar, etc. So let's talk more about the full utilization of bamboo. This picture demonstrates quite well, like the bamboo rods can be for food. The bamboo columns can use for bamboo engineering products like bamboo plywood. Then the branches, poles can use for bamboo pulp. Then the others can use for carbon sequestration. So I will go a bit detail into each section of products. So the bamboo raw material, the major space in engineering bamboo products is muscle bamboo in China. More than 60% of raw bamboo supplies is from China and has been adding lots of values like increase farmers' income, bamboo plantation, also environmental benefits like reduce soil erosion in the bamboo plantation. Bamboo products can entirely replace wooden products in almost all the end users. So in China, our annual harvesting is about 1.4 billion columns of bamboo, which equals 230 million cubic meters of timber. So this gives a huge market for the utilization of bamboo products. About the bamboo shoots, the production in 2020 in China is more than 8 million tons. So China is the largest bamboo shoots exporter. The value we analyzed with bamboo shoots is poverty reduction, food security. Also, the value-added products can be high-value utilization of whole bamboo shoots products. About bamboo handicrafts, we are one of the biggest manufacturer and exporter for bamboo handicrafts. So the value can be adding livelihood and employment opportunities, especially in the rural areas. And for the future value-added products can be healthy home decoration materials and substitutes for plastic products. About bamboo pulp and paper, the production in China in 2020 was more than 2 million tons. So the value added in this sector is a huge economical scale, and with modernized industrialization machinery, and the major material bamboo species used in these pulp products is Sombodia bamboo species. Therefore, based on the bamboo raw material, we can cultivate bamboo fiber raw material base. Then we can use bamboo plus pulp plus paper integration to think about high value adding in bamboo pulp and the paper sector. About bamboo extracts, so the two major chemical elements is bamboo leaf flavonoids and the bamboo dietary fiber. The production in China is more than 6,000 tons of bamboo drinks. So think about the value adding could be a healthy food and the pharmaceutical raw material with bamboo extracts. Then this is a high-tech products, bamboo winding composite. This is a new type of bio-based made from bamboo streams with a reason to go through two-dimensional winding process. For example, in the picture, I showed a huge bamboo winding composite pipe. So this is a great substitute for traditional materials as steel, cement, plastic, and non-ferrous metals. Then about the bamboo flooring, the production in 2020 in China is more than 7 million cubic meters. So the high value added in the future will be bamboo screenboard flooring and outer decking flooring goes for the future markets. About bamboo charcoal, this is an excellent substitute for wood charcoal products. The production in China was about 1 million tons. Then this value adding is with a massive processing, good economic scale. Then there are lots of high value added products concerned with charcoal, bamboo charcoal, like activated carbon for adsorption and filtration, also nano bamboo charcoal powders, fibers, etc. Then about bamboo plywood. So China is one of the market leader pioneer for bamboo plywood. Production has been reached about 7 million cubic meters. So the value to consider is to conserve forest and reduce the use of energy-intensive materials like other products. Then about bamboo furniture, we have been produced about more than 1 million pieces of bamboo furniture products. So the value adding in bamboo furniture could be considered more like cultural and green values with bamboo furniture sector. The last products could be bamboo services, which we consider as planting and breeding models under bamboo forest, like traditional Chinese medicine herbs. Also, tourism has been dramatically increased in current years, as well healthy and wellness industry has been combined together with bamboo services related. So when we're talking about carbon issues, so with less than 3% of the planting area, bamboo contributes for more than 20% of the total forest carbon sink in China, which means annual carbon sink is reached about 40 million tons in China. So the carbon storage of bamboo boards was estimated about 17 million tons of carbon every year. If we can fully utilize of China's bamboo resource, which can have like 140 million tons of standard coal and can reduce more than 300 million tons of carbon dioxide. So this figure, many of our experts has showed, it just shows how the carbon dioxide can release the advantage compared to 1 meter of other material will be more than 100 times than 1 cubic meters of bamboo. Then the energy consumption ratio of bamboo to concrete is 1:8, to steel is even reached to 1:50. So to conclude from the experience for full utilization in bamboo in China, So the value of one column of bamboo has increased from 50 yuan to more than 60 yuan current days. So we have paid high attention to sustainable development and the multi-functions of bamboo forest resource and production. Then we have designed specific machinery and facilities to meet the special market needs and also use the specific properties of local bamboo resources. Then there has been establishment of a series of policies to supporting the sustainable development of bamboo sector in China, including bamboo forest management policies and manufacturing processing related policies, and also in the tourism and tertiary industries. So because of time limitation, so I will end my presentation here. Thank you for all. Thank you.
Thank you very much for your presentation. And from Professor Wang's presentation, we have learned that the evolution of China's bamboo sector and the current market for diverse variety of bamboo products. Now we are heading to our last speaker today. Mr. Jasmine May de Leon is a graduate student from Philippines. Her study focused on the life cycle assessment of bamboo racket production in the Philippines. She has worked with various organizations on climate science education as the national coordinator for Climate Science Philippines. Ms. Jasmine, the floor is yours.
My fellow presenters, to the attendees and organizers of this session, a pleasant day. I am Jasmine May de Leon from the University of the Philippines, Diliman, and I will present to you our study entitled Life Cycle Assessment of Bamboo Briquette Production in Iloilo, Philippines. To start, I will first share to you a background of the study and then how it went about. Eventually, I will share to you the initial results of the study. Solid fuels have been long used in human history. They have been used for cooking and heating. Aside from heat production, using solid fuels have other emissions. This includes particulate matter, carbon monoxide, and polycyclic aromatic hydrocarbons. These are household air pollution that greatly affect the air quality. Furthermore, because of its minute size, it can penetrate the lungs that can lead to respiratory diseases such as lung function reduction, asthma, lung cancer, and chronic obstructive pulmonary disease. In the Philippines, 49% of the 96 million population are still dependent on solid fuel, and 48,000 deaths per year are attributed to household air pollution. This is according to Clean Cooking Alliance, an organization that promotes clean cooking technology. Furthermore, in the Philippines, for fuels, coal is still contributes mainly in the gross power generation as of 2021. And only 22% is on renewable energy, which includes hydro, solar, wind, and 1% only in biomass. Considering the country is an archipelago and dependent in agriculture, there is a potential for expanding using other alternatives for solid fuels, including biomass. An example of solid fuel is briquette. Briquette are compressed biomass that undergo densification technology, and it can be agroforest residue such as wood chips, rice husk, and coconut hull. Briquettes also have binders to keep its shape intact. Binders can be molasses and starch. Other than that, it can also have additives such as sodium nitrate as accelerants and calcium carbonate as whitening agent. All these raw materials are mixed and undergo the densification process. One biomass that can be used for briquette production is bamboo. Bamboo is locally known as kawayan and is known also for its wide range of applications. Studies have shown that bamboo can sequester carbon. This was done by Ecosystems Research and Development Bureau, or ERDB, wherein they studied 4 local species, which are kawayan tinik, giant bamboo, bolo, and bubo. Carbon analysis showed that the bamboo species can sequester or can store an average of 39 to 43% carbon. In the Philippines also, the municipality of Maasin has one of the largest land areas for bamboo, with 8,085 hectares of bamboo area and 2.42 million annually produced poles. Here, they have further explored the bamboo briquettes. The enterprise worked with government agencies for a science and technology-based farming and for production of bamboo briquettes, wherein more efficient carbonizers instead of earth-mount kilns are used for carbonization. The bamboo briquettes are made of carbonized bamboo waste from the production of their primary products, which are barbecue sticks and chopsticks. The briquettes are sold for less than $1 per kilogram. Bamboo briquettes have several advantages, such as being uniform in size, which means easier packaging and transport. It has also high bulk density, which means it can burn longer. An actual experiment was done by the enterprise, wherein they experimented between epil-3 as wood charcoal and bamboo briquette. They replenished the epil-3 charcoal 3 times and only once for bamboo briquette. Moisture content is also low, which means more efficient heating fuel. As fuels for cooking, briquettes have unfavorable impacts on air, health, and the environment. When gauging impacts of proposed alternatives to traditional charcoal, understanding the effects of combustion is only part of the whole process. To clearly assess the environmental impacts of briquette production, life cycle assessment or LCA methodology may be used. LCA is a methodology used to assess the environmental impacts of a product or service over the entire life cycle. The International Organization of Standardization, or ISO, developed standards for LCA for the methods and procedures to ensure comparability. The following are the phases of an LCA. Goal and scope definition, which is the phase that defines several questions focusing on what and why of the study. And the goal focuses what is the intended application, what is the reason for the study, and what are the limitations, and who are the target audience. And if it is applicable, the comparative studies must also consider what products to be compared. Next is the inventory analysis. This phase involves input of resources, products, emissions, and waste. Inventory analysis traces all of those components for accountability. The crucial part in this step is defining the products, byproducts, and even waste products, especially for a comparative study. Data can either be primary or secondary. Primary data are collected directly from the industry, while secondary data is from online databases and studies. Secondary data should also consider time-related coverage, geographical coverage, and technological coverage. Next is the impact assessment. Impact assessment phase translates the material and energy flows from stage 2 to impacts on human health, ecosystem, quality, and resources, or other impact categories. It involves mandatory steps, as mentioned in ISO, which are selection, classification, characterization, normalization, weighing, and grouping. The last 3 steps are optional. It is important to note that these impacts are best guess potential impacts and not necessarily actual impacts. Next is the interpretation. This stage involves reviewing, discussing, and analyzing data obtained. It is important to stick to the goals and scope of the study. This study may be done for every step mentioned, thus some answers to the steps may be changed. This makes the methodology iterative because of the possible revisions. Interpretation also involves completeness check and consistency. Studying LCA of briquettes will be significant to different regulations and policies. This include EO 879, wherein government agencies in the Philippines are required to use at least 20% of bamboo products to promote reforestation of bamboo. Next is RA 9003, or the Ecological Solid Waste Management Act of 2000, wherein it aims to reduce solid waste at the dump site by 25%. Next is assessing the impacts of briquettes promotes sustainable development goal number 7, affordable and clean energy, number 8, decent work and economic growth, 13, climate action, and 15, life on land. The local government of Iloilo also aims to have sustainable urbanization through planning or urban growth resilience and economic development. LCA briquettes help the industries for product research and development, strategic planning, marketing, public policy making. Also, LCA promotes the importance of circular economy, since LCA evaluates the impacts through a product's entire lifespan. To proceed with LCA, as mentioned, the following were defined for the goal and scope. The goal of the study was to assess the environmental sustainability of bamboo briquette production in Iloilo, Philippines, by identifying environmental hotspots in the life cycle of bamboo briquette production. Further, upon interview with a stakeholder, they are interested with 1 kilogram of bamboo briquette, thus was chosen as functional unit. Further, considering the process of the production, gate-to-gate analysis is only done, which will be further explained in the next slide. Further, LCA tool used was SIMAPRO with Recipe 2016 characterization. To fully implement the study, coordination with different stakeholders are needed. This involves email, phone call, meetings, and site visits. The lifecycle inventory, or LCI data, were taken both from primary and secondary data, which includes Kawayan Marketing, UPV, Bamboo Enterprise, UST, FPRDI, or Department of Science and Technology, Iloilo Electric Cooperative, EcoInvent, and also some related literature. The schematic diagram or the scope shows the life cycle of bamboo from cradle to grave, starting from the cultivation, which also includes gathering of the fresh bamboo, then the production of the primary products, and then the solid waste, which is the bamboo waste after production. This will be then collected. The bamboo waste is then carbonized using kilns or carbonizers, then grinded or shredded to powder form, then mixed with the binder and water. With the ratio of the raw materials, the mixture is then extruded to cylindrical shapes. The wet bamboo is now ready for drying. Then it is packed and ready for consumption. The consumption phase eventually produces ash and other emissions which could greatly affect or contribute to bamboo cultivation phase. For this study, only the gate-to-gate analysis is done, which is from the bamboo waste collection to bamboo briquette. This is within the scope of the manufacturer. Results show that carbonization scored the highest in most of the impact categories, except for water consumption, primarily because water was used for mixture of the briquette in the mixing and grinding state. Further, grinding and mixing also scored next to the impact categories. These are processes that use electricity and connected to the grid. To note, the data used was from the Iloilo Electric Company, a cooperative, wherein the data is solely on Maasin or in Iloilo. Thus, only 65% or 65% is still dependent on coal based on the electricity matrix. The impact scores overall showed low for bamboo briquette production. Global warming and human carcinogenic toxicity were the impact categories with the highest scores. This is mainly because of the emissions during carbonization, which includes carbon dioxide, carbon monoxide, and particulate matter. Further, land use was the impact category. My fellow presenters, to the attendees and organizers of this session, a pleasant day. I am Jasmine Meiji De Leon from the University of the Philippines, Diliman, and I will present to you our study or the business as usual production of bamboo briquettes show that carbonization and processes using electricity are the business as usual production of bamboo briquettes show that carbonization and processes using electricity are the hotspot processes. Bamboo waste carbonization scored the highest in 17 impact categories, and this is followed by grinding, mixing, and extruding. Impact categories with highest scores are global warming and human carcinogenic toxicity. To further decrease the impacts of bamboo briquette production, the following are suggested: to use more efficient kilns and also to consider renewable energy for the electricity mix. Further to consider in this study are the other alternative scenarios and sensitivity analyses of the data, considering secondary data were also used. I have reached the end of my presentation, and thank you very much.
For your presentation, and thank you for showing us a very interesting LCA case study on bamboo briquette production in Philippines. As the time is very limited, I would like to give the floor to my colleague Durai to briefly conclude today's session. Please.
Many thanks indeed, Ran5, for your great and excellent moderation for today's session. So many thanks indeed for that. And I would like to thank all the panelists here. Edwin and Salim, it is too early for you because you are guys in another time zone. Jaya and then Professor Lei and Jasmine, you are based in the same time zone, but taking your time to be presenting the cases here is highly appreciated. So I thank all of you for joining the session and providing us a great case study, specifically Jaya's case on Indonesia's like some power, on the cases like some comparing solar and like some biomass, who actually like some benefits in the case. In the case of the bamboo or in the case of like some biomass energy, it is the benefit to the farmers, the growers. In the case of solar, the benefit goes to the industry. So this is an interesting case. And secondly, the case from Professor Edwin is quite interesting for us, as the storage of the carbon is more in the plantation per se, and having the LCA done and the stages how we can amplify the benefits and storage of the carbon is quite interesting. So many thanks indeed, and it provides an empirical and scientific data for us. And the data set which he has produced will be used for plenty of like researchers and like researchers in the future. And Salim's case on the micro enterprise is quite interesting, and we would want to see much more smallholders, farmers like them benefiting out of the process. and Professor Ai Wang's case study on the evolution of the China's bamboo industry is a true case study and then this is an inspiration for the stakeholders of the bamboo sectors outside China to follow the stage, the 3 or the 4 stages, the pre-industrialization stage, industrialization stage, the co-economy stage, and the multifunctional stage is clearly important. And then it is important for others to understand. So we have to go stage by stage to reach the stage where China is now. And if we have to maximize the benefits to carbon, if we have to maximize the benefits to the economy, we have to utilize the maximum like biomass, not only utilize the 20% of the biomass. We have to utilize the biomass at the maximum. This is a very interesting case, Professor Lei, from you. And then finally, from Jasmine, I think she has done a splendid case study on LCA on the biomass utilization. As we mentioned in the beginning, energy is a very important area where the bamboo can play to contribute to the green economic development and also for the climate change and mitigation to bring the carbon neutrality at this case. So, and her recommendations on the modifying the clean, the renewable energy sources are highly valuable for the industries and entrepreneurs in the years to come. So many thanks indeed to all the panelists and to the organizers, and importantly to our moderator like Renfai. So I wish you a great day ahead to all of you. So, and also mainly to the participant, have a great day. Thank you indeed. Bye-bye.
Thank you. Bye-bye.